welcome to True Projects. In this video, we are going to explain about the project title Parking Slot Detection using Yolo and Registration of Empty Slot. Before diving into the execution, let me give you an overview of the project. Urban areas face a growing challenge in parking management due to the increasing number of vehicles and the scarcity of parking spaces. This results in drivers struggling to find vacant parking spots efficiently, leading to traffic jam, time wastage, and heightened pollution levels. To address this issue, the project focuses on developing a parking slot detection system utilizing YOLO, You Only Look Once models, a powerful deep learning based object detection algorithm to swiftly identify empty parking spaces in real time, automating parking slot registration and enhancing efficiency in parking management processes, aiming to elevate urban parking challenges. Traditional parking management relies on manual monitoring by attendants or basic sensor systems to detect vehicles in parking slots. However, these methods are labor intensive, time consuming, and prone to human error. Basic sensors lack accuracy and fail to offer real time updates on parking availability, and they can be costly to install and maintain. The proposed system utilizes YOLO models such as YOLO V5, YOLO V6, YOLO V7, and YOLO V8 for parking slot detection. YOLO is a deep learning based object detection algorithm known for its speed and accuracy in identifying objects like vehicles in images and videos. By leveraging YOLO models, the system automates the detection of empty parking slots in real time. This automation enhances accuracy, reduces manual intervention, and offers real time updates on parking availability, overcoming the limitations of traditional methods. Also, the system helps register empty parking spaces, making parking management even better. Performance will be assessed using standard object detection metrics like MAP, mean average precision, and recall to gauge the accuracy of detecting empty parking slots. Additionally, the system's processing speed will be evaluated to ensure real time performance. These evaluations ensure the system reliably identifies available parking spaces accurately and swiftly, vital for efficient parking management. This project benefits multiple groups. Parking lot owners will manage spaces more efficiently, increasing customer satisfaction and potentially earning more money. Drivers get real time updates on available spots, saving time and reducing stress. City officials can use system data to improve parking strategies and ease urban traffic congestion. To implement this project, we need software and hardware requirements. Hardware requirements of the project are operating system of Windows, processor of Wi-Fi and above, RAM of 8 GB and above, hard disk of 25 GB and above. Software requirements of the project are application is Anaconda, primary language is Python, front-end framework is Flask, back-end framework is Jupyter Notebook, databases SQLite 3, front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Algorithms used. These are the algorithms built in the project. And here the YOLO V5 model outperformed the other algorithms, and that is the reason we have deployed it in the front end. Let me explain you what YOLO V5 is. YOLO V5 or You Only Look Once version 5 is a cutting edge deep learning model specializing in real time object detection. It excels at both speed and accuracy, making it ideal for tasks like self driving cars and video surveillance. YOLO V5 prioritizes user friendliness and offers diverse pre trained models for various needs, while also allowing for customization for unique objects. Overall, it's a powerful and versatile tool for object detection in numerous real world applications. Now, let us execute the project. To execute this project, first we need to open the code folder which contains the project source code files. So here, this is the sample folder in which we have the test cases which we will use during the execution. So here we are having in total 159 images which we will use during the execution. And this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is the templates folder. This folder contains all the HTML pages used in the project. It includes files like index.html, about.html, and more, which represent different pages of the website. This is YOLO v5 folder in which the data set is split into train and validation. In the train folder, we have the images folder as well as the labels folder. In the images folder, we have the images which are used to train the YOLO v5 model. And here in the labels folder, we have the labels or annotations for objects in the corresponding images. Each label file corresponds to an image file in the images folder, providing details about the object's location and classes within the image. These label files often follow the YOLO format, where each line represents a detected object. Each line specifies the object's class index followed by its bounding box coordinates normalized to the image dimensions. So here, let me open this label. So here we can see the first one is the class index, and these are the coordinates of the bounding box which are used for detection. So here, this is the first label for the image this. So here in the validation folder, again we have the images folder as well as the labels folder. So in the images folder, we have the images which are used to evaluate the performance of the YOLO v5 model. And in the labels folder, we have the labels or annotations for objects in the corresponding images. So each label file corresponds to an image file in the images folder, providing details about the object's locations and classes within the image. These label files often follow the YOLO format, where each line represents a detected object. Each line specifies the object's class index, followed by its bounding box coordinates normalized to the image dimensions. And here we have the text documents for readme.dataset and readme.roboflow. Similarly, YOLO V6, V7, and V8 folder contains the same images, but they are annotated differently because each YOLO version requires its own specific type of image annotations for training and testing the models effectively. Having separate folders help keep the dataset organized and ensures that each YOLO version receives the correct annotations it needs to function properly. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. Here, I'm copying the path. Now open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. So here I'm typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address. Localhost, which is this, and port, which is this. Now copy this local link provided by the Flask framework. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. If we are a new user, we need to register first. So click on sign up button here. So here we need to enter all these details to register, but I have already registered. So click on sign in. So here we need to enter the username and the password which we have registered, which are static, and then click on login. We have logged in successfully and we are redirected to the prediction page. So here we need to upload the images of the parking slot, and after uploading the image, the application will detect the empty slot and we can even register that slot. So click on choose file. So here from the test cases folder, I'm selecting the first image. Now click on open. So here we can see that the image is loaded. Now click on upload button. So this is the uploaded image, and here we can see number of slot available. So this is the uploaded image, and here we can see number of slot available is 1. So here we can see only one slot is detected here, and on top of the bounding box we can see here it is written empty, and we even have the probability score which tells us the confidence level for the detection. So, and here we can see the number of slot available is 1, and here we have the option to register that empty slot. So we need to enter the name, full name. So here I'm entering the name, email ID. So this is the mail ID, and here we need to enter the phone number. So I have entered the details. Now click on submit. So here we can see success, check your mail. So here we need to check the mail for the confirmation of the slot. So here I'm going to open my mail ID and show you. So click on Gmail. So here this is the email which we got. Your slot is booked. So it tells us that the empty slot is booked and we can park the car. Let us close this. Now let us upload some more images. Click on detection link here. Click on choose file. So this is the image which I'm going to upload. Click on open. So here we can see that the image is loaded. Now click on upload button. So here this is the uploaded image, And here we can see that the empty spaces are detected with the red color bounding boxes, and on top of the bounding box we can see it is written empty along with the probability score, which tells us the confidence level for the detection. So here we can see 4 slots are available. So 4 empty slots are detected here. And here we have the option to register for those empty slots. I have already shown you how to register. You just need to enter your name, email ID and number, and once you enter the mail ID you will get the confirmation to your mail. So you just need to enter these details and submit. So in this way the empty slots will be detected, and we can register those empty slots and get the confirmation to our mail ID. Since I have already entered my mail ID, I am not going to enter again. So just click on submit once you enter all these details. Let us upload one more image. Click on detection link. Click on choose file. So from the test cases folder, I'm going to upload this image. Click on open. So here we can see that the image is loaded. Now click on upload button. So here this is the uploaded image, and here we can see that the application has detected 3 empty spaces with the red color bounding box, and on top of the bounding box we can see it is written empty, and we even have the probability score which tells us the confidence level for the detection. And here we can see number of slot available is 3. So we are having 3 empty parking slots to park our cars, and here we can register those slots entering these details. Once we enter these details we'll get a confirmation to our mail ID telling that the slot is booked. So we just need to enter these details. I've already shown you how to do this. So in this way, by uploading the parking area images, we can detect the empty spaces for, for the parking, and we can even register those slots entering the basic details, and we will get the confirmation to our mail ID. Now click on graph link here. So here we have precision and recall graph of Yolo, precision recall curve. On the x-axis we have recall score, and on the y-axis we have precision score. And here this is the F in confidence curve, and this is the confusion matrix for Yolo. And here we have the precision comparison graph. On the x-axis we have the precision score, and on the y-axis we have algorithm name. And here this is the recall comparison graph. Here on the x-axis we have recall score, and on the y-axis we have the algorithm name. And this is the MAP comparison graph. Here on the x-axis we have MAP score, and on the y-axis we have algorithm name. So the algorithm which is performing best will be used for prediction. Now click on sign out button here. This project will make parking easier for drivers, help parking lot owners manage spaces better, and give city planners useful data to reduce traffic in cities.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.